Hey, it's Dan. Let's do some math. Do me a favor, like and subscribe, hit all the buttons. Let's go.
The following, and I didn't put directions up here, but we're trying to simplify this. Now, in algebra, a problem is not considered to be in simplest form as long as you have a radical in the denominator. So you can't have a square root or a cube root or a fourth root or any kind of root, any kind of radical in the bottom. So this is not in simplest form, even though it is pretty simple. So the first thing that I might do is realize that I have two separate square roots here, and I can write this underneath one square root. So this is equivalent to this. So you'll notice on the one hand, I don't have separate square roots, I just have one square root, but you notice some other things changed also. I went ahead and said, and did this division. So since 2 minus 1 is 1, I only have x to the first power there. And since 3 minus 1 is 2, I just have y squared. So I was able to get rid of the variables that way. So when you divide monomials, you subtract the exponents. So this became this. And now I'm going to rewrite it separately. So in other words, I have the same thing, but I've written separate square roots. And then the next thing I'm going to do is, since this is a square root, 2 goes into 2 one time. So I have y to the first power here. And I don't have any left over, so I don't have a y under the radical. So I just went ahead and did that. So secret 2 here, because it's a square root. 2 goes into 2 one time, so this is y to the first power, and there were no remainders, so I don't have a y under here. The 5x is still there, and the square root of 2 is still there. So I simplified everything that I could right there. And now what I'm going to do is do what you normally do. So normally, to get rid of this radical in the bottom, and I did some simplification to get to this point. But now, to get rid of this radical in the bottom, I'm going to multiply the top and the bottom of this by this denominator. So since this is the square root of 2, I'm multiplying by square root of 2 over square root of 2 times all of this. Now, the reason I can do that is anything divided by itself is 1. So I'm essentially multiplying this by 1, but it's a fancy form of 1 so that I can get rid of the radical in the bottom. So anyway, do this multiplication. This times this, square root of 2 times square root of 5 is square root of 10. The x is still there. The y didn't change. It was on the outside. And the square root of 2 times the square root of 2 is 2. The reason for that is the square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. But I just think you should get in the rhythm of saying the square root of 1 times the square root of 1 is 1. The square root of 2 times the square root of 2 is 2. The square root of 3 times the square root of 3 is 3. And the square root of 4 times the square root of 4 is 4. And the square root of 5 times the square root of 5 is 5. Now, I used to do this in the classroom until kids would just beg me to stop. But if you don't go crazy, if you don't make a fool of yourself in front of them, they will continually say they don't know what the answer is when you say, okay, so what's the square root of 6 times the square root of 6? You'll see them thinking, and you know that you need to do a dry run until they beg you to stop. So square root of 11 times square root of 11 is 11. You shouldn't have to think that hard about it. It should just be automatic. It should just come naturally. So square root of 2 times square root of 2 is 2. And notice I don't have a radical in the bottom. I can't simplify this any further because 10 only breaks down to 5 and 2, and those are both prime. So I've simplified this as far as I can simplify it, and that's my final answer. One final note, I'm doing this assuming that all the variables are positive. So I'm kind of doing this on a very low level, like a middle school level or an Algebra 1 level. If you're taking an Algebra 2 honors course, you'll have to use some absolute values in the problem, but that's a topic for another day. I'm just doing this on a very low level, and we're simplifying, but we are assuming that all the variables are positive. So keep that in mind. If you're in Algebra 2 honors course, this isn't the perfect answer. This is just kind of close to the right answer. It doesn't have the absolute values in it. All right, see you later.